Okay, so this time I ditched the really hideous plywood gantry that was in the last very short video, mostly because it's ugly, it's heavy, and it really didn't add any rigidity from the previous aluminum version. So we went back to that. Also, now I've got this nice little motor mount here that I built, which is from a scrap piece of quarter sawn red oak from my fabulous, wonderful, really awesome dining room table I've been building since the dawn of time. And while I was at it, went ahead and built this Y-axis carriage. You see here, we've got a plate where I installed the threaded rod for the lead nut, if I can actually get the words out. It's still pretty early in the morning here. And I really wanted a UMHW plate for the back of the Z-axis, but couldn't find one for a reasonable price, so I found some cutting boards. In fact, you can see the old half of this thing here. Little 12 by 24 cutting boards for a whopping $6 each on sale at Walmart. So I took two of those, epoxied them together, and went ahead and tapped it for these bolts, little M6 by 10 bolts that nicely go into the VXB bearings here that are on the back. If I haven't mentioned it before, this is pretty good size. This is a 20 millimeter hardened steel rod. They're about 50 inches long, which is too big for this table. And I haven't really decided yet if I'm going to cut these, buy shorter rods, or just build a bigger table for this thing once I get this table out of here with my Spanish windlass I'm using for clamps down there. So in the meantime, this actually works pretty well. We've got a little bit of binding on the rails, and I think that's because the sides of the gantry aren't quite lined up. So with two bearings on each side, there you can see them, and there's two obviously on the other side of that plate. This whole thing really needs to be very square for it to work. And I noticed yesterday, if you push this thing, after a little bit, I don't know if it's really super visible, but there's a little bit of stepping between the left and right sides. So this thing actually jumps, and if you do that for a little bit, you get kind of a resonance going on, and you can hear the lead screw tapping. Also need to put a bearing on that side. Over on here, the motor mount, which I may post the SketchUp design for that, is actually working out pretty well. That wood is 1.5 inches thick. That's a NEMA 23 dual shaft motor. It's pretty high torque. And down in there, you may be able to see the shaft coupler, which is why the slot is cut out on the top, so I can get to the set screws on that. On the back, we've got a really cheap little eBay bearing for the 8mm 4-star Acme rod for the lead screw. Need to put one on the other side, but because of the way my workbench is set up here, a very nasty workbench, can't really get to that side at the moment. I also got these flange bearings for flange blocks to support the rods. Those are the rails. Those are bolted through the aluminum plate, and we got nuts on the back side. Nuts. And you can see, just based on the number of holes in there, that bolts coming out, that this is a fairly complex piece. I actually managed to cut those these holes here to 7/8 with a Forstner bit on my really cheap ancient drill press that has more run out than I care to think about. Another issue I'm dealing with at the moment is I'm just using aluminum square tubing to connect the opposite sides here for the frame. Need to go something with a little more rigidity to it. I'd like to replace these rods with a fully supported rail and some open bearings, but that's a little bit out of my budget at the moment. So I'm thinking this is probably going to work well enough once I get the frame squared, and I may go ahead and add another piece like this. I'll just clamp it in place and see if that makes this thing a little bit more solid, because even though it is quite a bit more rigid than the first version, it does have a little bit of play in it, which may be also adding to this sort of bumpy movement that we've got on the rails. Also need to figure out where I want the lead screw to go for the Y-axis, or to drive the gantry. It's actually the X-axis. On some other machines, they actually use a mobile table that are a table over the lead screw, and the lead screw would go from the center here just all the way across, and it would move the table, but I don't really like that idea. The other option is I could put the X-axis motor up on the back of the carriage and then have a shaft going to both sides, since I have dual shaft motors, and then I would need a belt or a chain to come down to actually move this thing. A chain would just come down here to idler sprockets here. But again, that's some money I really don't want to spend, and trying to do this as inexpensively as possible. So anyway, that's the state of the union. Also need to figure out a wiring solution. So this is probably going to wind up going through some sort of track, like you may have seen on some other CNC builds out there. But overall, it's pretty. I like the motor mount. One trick that seems pretty obvious in retrospect, but simply did not occur to me, was when you're drilling something like the motor mount that has a lot of holes that need to be really precisely aligned, and you don't have a CNC machine yet to do it for you. I just did this in SketchUp, and couldn't figure out how to make the drill holes with the center mark, so I just added some guides, and it's pretty close. It's close enough. And then while working on this, I just taped, or actually glued, this paper. Probably should have taken a picture of this before, but you can kind of see how that matches up, and it's to scale, which is one of the things that you want to make sure when you're